Good morning, everybody. That'll be a tough act to follow. Thanks for the panel. That was pretty illuminating. I'm definitely thinking now of what is the contract. That's going to come out of my mouth a lot more often now. So I'm here to introduce Epic Blockchain Technologies. So our core mission is to be a first-class ASIC design house. So what that means is we're making microchips to support the blockchain. So fundamentally, we want to be the underlying processing power of the blockchain. And as I've been talking to investors and miners over the last day or two, that kind of long-term vision around that is to be the Intel inside the blockchain. So that's very much looking at how do we help these networks grow? How do we give them the processing power that they need to do transactions at speed and volume that are going to allow us to do things like trade security tokens, similar to the way we trade equities right now. Because if you think about 3 transactions a second, that doesn't compute very well when you compare that to a NASDAQ or a New York Stock Exchange. We need to get more volume, and a big piece of that is the processing power and the processing technology underneath that. And to kind of set that up, I'm going to do the world debut of our video, so I don't know if we can cue that up. I don't know where that's coming from, but if Dave, you guys can pop that up, that'll be help us kind of set the tone of what we're up to. Oh. Crypto asset mining is a $1.5 billion global industry that's growing rapidly. Blockchain networks are severely limited by the amount of processing power they have available, which limits their earning potential as well as their usability and scalability. That's where Epic Blockchain Technologies comes in. Epic has designed an application-specific integrated circuit, also called an ASIC for crypto asset mining. This ASIC will rapidly improve performance and overall profitability for crypto asset miners.
Crypto asset mining requires hardware to perform complex operations. Standard CPUs are just not up to the task. GPUs offer higher performance, but a much greater power output. Epic ASIC 1 is a Bitcoin mining chip optimized for high frequency and low power, utilizing the latest methodology in digital design. Epic ASIC 1 will generate industry-leading hash efficiency, a critical factor of success for crypto asset miners.
The market is just getting started. As enterprise adopts the blockchain, the need for custom ASIC designs will only increase, opening up many different channels to serve with ASIC solutions. We will offer flexible business terms to commercial miners, potentially moving a core equipment expense from a CapEx to an OpEx, capital to operating. Secondary chip markets targeted to individual miners will open downstream as commercial miners upgrade to future designs.
More and more industrial crypto asset miners are coming online, and demand for this has never been greater. Our team is on schedule to deliver an ASIC shuttle run in Q2 of this year, and our second generation designs are already in development. Epic is ready to meet the demands of this fast-paced industry, and we are firing on all cylinders.
The growth of commercial scale crypto asset mining is creating incredible demand for ASICs. The crypto asset equations are increasing programmatically in difficulty, driving even more demand for processing power. Epic is that power. All right, thanks for that. That was the world debut of that video, so let us know what you think. So with that, I'll jump into some slides. So, forward. There, alive? No, killed it. There, big green button. Yada yada disclosure. So, kind of in tune with what we were talking about in the video there is really the way we frame this to the more layperson investment market. It's a pick and shovel play. So we're looking at, we've seen a big growth in industrial mining. So that's lots of guys taking huge amounts of megawatt power, throwing that at mining rigs. And really what they're in short of is not so much electricity, they're in short of the actual equipment and the supply chain to suck down that energy and convert that into Bitcoin, convert that into Litecoin, convert that into different mineable tokens that we're looking at. And that's a big constraint around how we're going to be able to grow and drive the processing power over top of that. So we need to diversify that supply chain and generate more advanced equipment in that. So if you think about GPU and GPU mining, those chips were made to play video games. They weren't made to do mining, so we're working much more around how do we actually do the processing and the specific application stuff that we need to be doing on those chips to make sure that we can grow faster and get more mainstream with how the blockchain works. So the classic TAM slide, so we're kind of looking at that. So this is really looking at how many ASIC chips are available to be sold just to mine Bitcoin. That's about a $1.5 billion market. as the hash rate goes up and the hash difficulty goes up, the more sophisticated chips are needed, the more chip volume is needed. So that's really where we're looking at with our first product. That's that target market there. So as I kind of alluded to, there's a supply chain constraint. Pretty much everyone's out there buying their equipment from Bitmain, Bitfury, which are great companies that build really fantastic technology. They're the dominant miners. So if you think about that, you're buying equipment from your biggest competitor. So we need to kind of diversify that supply chain so there's an independent supplier, and that's really where we're looking to be. You know, our kind of catchphrase around that is we design, we don't mine. So we're only focused on building chips and delivering them to the miners to do the mining. We're not going to mine against them. Their current suppliers mine against them. So where we're really focused in the long term is unleashing the power of blockchain. So allowing those enterprise supply chains, allowing us as consumers and users of cryptocurrencies to get much more higher velocity, higher volume, more sophisticated transactions. And what that requires is more sophisticated computing power. And where that computing power is going to come from is those chips. So you think about, you know, Windows 97 only worked very well because the Intel Pentium chip underneath it allowed your spreadsheet to compute those macros much more effectively. So we need to bring the chips and the applications together to make it a more effective system. So about us, we're from Toronto. Like many of us, we have an office in New York. We're launching our first chip in Q3. Really where we see this going is really combining that hardware and software play to grow together. So kind of go back to that kind of Intel and Microsoft analogy. As they grew through the 80s and 90s, that was very much because the interlock between how they were developing their products. So who's our customer set? So a few of the miners have been here. Get the chance to talk to HashChain earlier today, DMG as well. So there's a bunch of big industrial miners have taken down money from Bay Street and Wall Street to drive this. They're kind of our core initial customer. When you look at the middle ground, the investors in the space, the guys who are trying to fund and move these cryptos at velocity. And obviously the bottom level of that, there's the large equipment manufacturers. So those guys we'd be interested in licensing and wholesaling our product to after we get into market. So really, where's the advantage? What is the product? So it's about a 30% performance improvement over the S9 spec. So fundamentally, that's either going to give you two options. You can pull down and use less energy to mine the same amount of hash, or get 30% more hash power. I suspect that most of our customers will take that 30% more hash power and get themselves a computing advantage. For the nerds in the audience, here are the specs. Earl, our CTO, will be happy to talk to you about how that works in more detail, but fundamentally where you see the advantage is coming from the joules per gigahash. So that's fundamentally the energy usage that goes into each chip to produce the hashing power that comes out and produces a Bitcoin at the end of the day. So how do we make money? So our kind of mainline product, our first product at the door is going to be for industrial crypto asset miners. So that's going to be a SHA-256 miner, which produces Bitcoins. We're going to either IP license that to larger equipment manufacturers. Most likely we'll be just selling those chips raw directly to the miners. Underneath that, we're trying to talk to all the equipment manufacturers, so the gentlemen who are building rigs and building servers more ideally. So that could be everywhere from Dell all the way over to your kind of Canons and Avalon miner type guys. Where we're really excited is working in the blockchain platform developer space. So that's working directly with the operating system developers. So we could be working with a Polymath to help them make their security tokens transact faster. So how do we build custom hardware underneath that system so they can transact tens of thousands of trades per second and get them much more higher velocity, higher value in their network by using dedicated hardware. And we're working on closing our first customer in that space. That is going to be my core focus next week when we get back to Toronto, is closing that deal so we can work in conjunction with a blockchain platform developer to put an ASIC underneath their system. And as that rolls out, that'll open up more ASIC-resistant opportunities, which will be interesting. The miners in the room will know what that means. And then we're also helping existing miners optimize the code that they're mining with so they can get more power out of their GPUs and get more ASICs efficiency. So how do we do this? So fundamentally, we start with a digital design. So that goes through how does this chip going to get laid out? What kind of math does it do? We turn that into an FPGA, which is essentially another format of board that we can use to test that out and validate that the math works and the physical hardware's in place. And then we take that into the actual physical production of the chip, which is where we're at in our current product development. We're in the back end phase of that, so that's actually figuring out how does that chip physically get laid out so that we can go and fabricate it at a foundry and actually produce the physical hardware. And that'll be our next step that we'll be into in May and June. So our real goal, where we want to be, is talking to as many application developers as possible and looking for who's going to be our Microsoft. So there's going to be 10 to 15 companies we want to go engage with, build that custom software with, and kind of have that Intel-Microsoft relationship going in terms of how we're going to use our hardware to help your software perform better and drive a bigger adoption of that technology. And so that kind of group looks a little bit broader. Obviously, we just continue to work with the miners around that and have that. And then kind of that middle layer, we want to work with those big application developers. How are they going to get better performance on their system? Not just code, you have to have the hardware and those systems and the servers to run that code. And if you don't have the underlying chips inside those servers, you're not going to get the scale. And then obviously that expands out even a bigger market in terms of what the OEM potential is, so we can be licensing with our foundries or give them the ability to keep selling our IP out, which is a very exciting opportunity that we're working on now. So this is a bit of a phase in terms of where we're at in our product roadmap. So this is where we're at with our SHA-256 ASIC. So you can see right now we're in phase 2, so we're in that back-end physical layout position. We're moving into that sample run. So the sample run will allow us to give miners actual sample chips that they can run in their data centers, validate that we can indeed do that 30% higher performance, understand how they can implement that chip into their environment and put power to it in order to get that hash rate out. And our goal is to have a mask completed, so that's actually the stamp. You would think about it as a stamp in terms of making those chips at high volume, so we'd be able to produce millions of them at a time and put that production out into market in late Q4, rolling into 2019 as we ramp that up. And the kind of long-term path is getting access to the 7-nanometer process, which is the most advanced chip form factor we can get into, and that's a developing process that's happening at the foundries now. So this is kind of a broad view of what our product roadmap looks like and our product portfolio. So we're working on the SHA-256 ASIC right now. We're starting the R&D on the platform-specific ASIC, so that's working with the protocol developer to integrate their operating system down to the chip level so they can provide that to their customers, the developers in their ecosystem, and the different nodes that are going to work in their ecosystem so they can increase the volume and velocity on the network. That's going to open up also opportunities with the as we onboard more engineers to that, we'll be able to do shader and firmware code. So fundamentally, that is writing code down to the chip. And so the way to think about that is if you look at a GPU, it's kind of a general purpose unit, really a graphics unit, but it's general in its usage. We make it much more specific to be running that mining algorithm you're trying to run off. So you're trying to mine ETH on top of a GPU, we'll be able to write some code down to that to get you some higher performance bounce off that. And in conjunction with our platform development that we're in process on now, we're going to open up some ASIC-resistant algorithms. So what's currently not able to be mined on an ASIC is being mined on a GPU. We're going to open up at least one algorithm out of the gate off of that, where we'll be able to provide miners, as well as the protocol developers, more importantly, access to ASICs to run that algorithm over top. So our real goal there is to work with the protocols to make sure that we're enhancing the value of that protocol, not giving miners an opportunity to destroy it, because there's a bit of a conflict around that in the marketplace. And then our kind of long-term view is to continue to rinse and repeat those product lines, enhance them, iterate them as Moore's Law works in our advantage. So every 18 months, the ability to do computing will get more valuable, and that's pretty much where we have to present. So we're going to be just outside the door. If you guys have more questions, happy to take them. We have some cool wireless chargers, so come pick those up so we don't have to lug them back to Toronto with us. And as we kind of said, we're trying to be the Levi Jeans guys of this mining gold rush. Supply those picks and shovels to the miners, as well as really dig in with those application developers and help those protocols be more valuable, more extensible in terms of what they can do from a processing perspective, so we can get more people on blockchains sooner rather than later. I think hopefully that's my contact information on the next one. Maybe. There we go. Email me anytime at Howard Scott J on Twitter if you want to tweet me. And thanks very much.